Okay, number 4 is somewhat problematic. I'll tell you why. This function sine x over x is undefined at 0. But I do know from what you took in Math 121, Calc 1, that you know the limit, I'll write this over here, limit as x approaches 0 from the right of sine x over x is just the number 1. So I would just simply define that if f of x is equal to sine x over x, I would define that f of 0 is the number 1. All right, that's what I do. All right. So I want to go to the whiteboard, and again, it says use Simpson's method, S4. I'm glad they're using low numbers because it's easy to write down. And what I want to do is go to the whiteboard and do that. All right. So let me put that down. And again, what I recommend is that if you're using Simpson's method, that you're going to be writing down Simpson's rule. Let me put that down for you. So a to b. Whoops, I do that all the time, don't I? So a to b, and then you got this f of x dx. And then they say, a good approximation of this is going to be b minus a over 3n. And then get just, I say that if you look at it, not that we derived it, but you say it's got a pattern to it. So f of c1, then 2, f of c2. And then it keeps the pattern 4, 2, 4, 2 until it eventually hits the 4, f of cn minus 1. And then there's last but not least is going to be the f of b. All right? And again, it's approximated. Again, I know I've been sloppy here, but it's an approximate of the value of the integration. So let's write this down. So what are we doing over here? The problem we're working on is problem number 4. Right? So number 4 is going to be an integration from 0 to pi over 6. And it's going to be sine x over x dx. A couple of things I need to write down initially. I need to write down what f of x is, the integrand. The other thing I need to write down is I need to clarify that f of 0 is going to be the number 1. Right? I'm going to say that from the beginning. Now, granted, what do I mean by that? I'm saying the limit as x approaches 0 from the right side of f of x is 1. All right? So I can say the function is essentially 1 at that point. But it's not defined there. All right? But if you drew the picture, you wouldn't see the hole, I'll tell you that. So what do I do over here? I write it down. Right? This is going to be approximately equal to, well, b minus a, that's going to be pi minus 6 minus 0 over 3 times n. And what's the n here? It's an S4. All right? So 3 times 4 is 12. All right, got this. I'm going to write this down now. What's f of a? It's f of 0. Then what do we get? We get 4 times f of. Well, I forgot to write that part down. All right? So remember, it really wasn't bad to do. I guess I should write that down somewhere. So CI is going to be the a, which is 0, plus pi over 6 minus 0, which is pi over 6, divide by 4, so pi over 24. All right? Not a bad number. So what do we get over here? Well, I'm going to do 1, so it's going to be pi over 24. Plus 2, f of, well, I'm doing number 2 now, so it's going to be pi over 12. Plus 4. Now I'm sorry, I said plus 4, I didn't write 4. It's going to be, let's see, 1, 2, 3 of these things. It's going to be pi over 8. Plus, all right? Let's not get confused too much. We did 1, 2, 3. Now we're at 4, right? What's 4 going to give you? Pi over 6. It's the endpoint. All right, we clean up a tiny, tiny little bit. And I'm going to say, basically this is going to be equal to, let's see, pi. 6 times 12 is 60 and 12, 72. F of 0 plus 4 f of pi over 24 plus 2 times f of pi over 12. No, I'm not expecting anyone to compute that, not without a calculator anyway. Put a little box in this guy over here. And what I'm going to do is just look at the key now, see how we did. And what's the key say? Let's take a look at it. And I got to scroll down to the key. Yeah, I see the pi over 72, good news there. I see the f of 0. I see 4 times f of pi over 24. Then I see 2 times f of pi over 12. Then I see 4 times f of pi over 8. And then I see, last but not least, f of pi over 6. I also see the approximation there. And we're good. Thank you.